So I wanted to make an entire slide deck to theme after where the world things are, and then I realized that it's Sued to Death by HarperCollins, and so you only get the cover. So this is uploading, and this is yours truly. Anyway, I'm Aymeric. I've been a Django core developer for 2 years now. I've been working on features that have made your life annoying at every new release of Django. I've added support for time zone in 1.4. I've worked a lot on Python 3 support in 1.5. I've changed the whole transient stuff in 1.6, and I'm bringing even more breakage in 1.7 with uploading. So this is my attempt at justifying myself, and so I can just point people to the video and they won't annoy me. Besides, I'm the CTO at Oscaro, and I'll tell you more about Oscaro during my 1-minute sponsor speech tomorrow. So first, who in the audience has never heard about uploading before? People don't dare raise their hand. So everyone knows everything about uploading already? Or maybe you just read the program. Anyway, uploading is really two things. First, it's a step in Django's initialization sequence where Django is going to import all your models from all applications, and so that's why it's called app loading. Django looks at install that and imports models, and it stores them in a cache, so it can easily find models when it needs them. Besides, it's also a project, and that's, well, the core of my speech, that aims at improving that part of Django with two main directions in mind. The first one being to provide extensibility, that is to give some control to developers on this process, and the other idea being to make it more robust. There were a bunch of edge cases that weren't dealt with properly. The canonical ticket for this feature is ticket 3951, which is add support for custom app label and verbose name, which isn't very explicit considering what I've just said. And it was originally written like this. Once the hot club of friends opens and we have more third-party apps, the probability of clashing app names will increase. That means there's an increasing likelihood that two apps will have the same label, and so you can't deploy them in the same project. We can fix this by allowing users to define a custom app label in the settings file. We can. In addition, we can add a verbose name for apps at the same time. And then it gets fantastic. This possibly breaks quite a few internals if people are using them, and needs to wait after 0.96 to be considered. It went a little bit longer, and I thought one experienced contributor would better recognize the ticket like that, because it was opened on February 27th, 2007, and closed on December 26, 2013, and over these 7 years you have 150 comments with various levels of despair and anger. And the thing become a kind of big ball of mud, and all issues related to application got doesn't duplicate, and so get really messy. So this means that many people have worked on this project during these years, and I want to thank them all because they've paved the way for what I eventually did. Maybe the most interesting step in there is the Python sprints in 2008, because that's when people realized that it would be a bit more complicated than initially envisioned. And there's a wiki page that summarizes 3 days of efforts and concludes that, whoops, we've been a bit ambitious. So the original proposal around that time, and it's in the ticket description, proposes to introduce a new syntax in installed apps. And so instead of just referring to a package name, you could introduce some additional information about your apps thanks to an app function. This is quite straightforward. It looks a lot like how URL counts have evolved. Initially, you had just tuples, URL counts, and eventually there was a URL function that was introduced, and you could write keyword arguments. And so here you see that in addition to Django.concrete.auth, well, for this project, there's a custom.auth application that's added with a different app label to avoid the conflict and a different verbose name. the final implementation looks a bit different. Instead of having syntax in installed apps is kept as just a list of strings, except that you can refer to a class instead of just the root package and application. And that class is what I'm calling an application configuration, or an app config. And it must inherit app config, which is available in Django.apps, a new module in Django 1.7. And there you find pretty much the same information as in the previous example. You declare the name of the app, its label, and its global name. The reason for using a class is that it provides better extensibility. For instance, that makes it easy to inherit and change a few bits in a class, or to override methods. Well, you could do all this with keyword arguments, but it just feels more natural with classes. Now, none of this was my motivation for working on this topic. My work was triggered by a completely different issue, and I'm going to demonstrate it with an example. The reason is obvious, but we'll see that later. Let's imagine you have this code where you register a receiver for the request started signal that says the time at which the request started, and another one for the time at which the request finished, and then you compute the duration of the request, and maybe you're going to log it somewhere. Here we will just print it. And if you run that code on the run server, it runs perfectly fine. It shows the request, the time taken by each request. And if you run it under JUnit, for instance, in production, you get an exception, which is fantastic, which means that the request finished signal ran, but not the request started. So bugs that happen in production are fantastic, and well, this is the root cause is that Django doesn't have a well-defined initialization sequence until 1.7, and specifically, you never know where you can register your signals. And that's what I wanted to fix, because we had signals related to billing, and you don't want to miss events related to billing in general. Okay, so now we're going to step back for a few minutes and think about why does Django need an uploading process after all. So this looks complicated, maybe we could just do without it. So to demonstrate this, we'll take a very simple model of a monster who has a name and a slayer, because monsters tend to get slain in stories. So this is just a regular Django model with nothing fancy. And once we define this model, the ORM gives us a very complete API to query it. And for instance, we can fetch Heracles from the database and then ask for the list of monsters that Heracles has slain. Heracles tends to want the monsters rather than slay them. He's slain these 3 monsters in his 12 works. And here, I have to ask a question. I've used Django the complete.auth model user, so that's just built-in code from Django, and suddenly I can call Heracles, which is a user, .monster slain. And that's just weird, because there's nothing in my code that says anything about monsters, and suddenly I can query them. So if we want to find out how monsters get into the game, we can simply introduce an exception in the class, and that way we will see at which point Django imports this class and starts using it. So for instance, we were Django admin PY shell. So I'll spare you the entire stack trace, which is a bit long, but you see that at some point the shell command, well, its implementation is going to call appcache.getModels, where appcache is an object that's defined in Django.db.models.loading, so you must see where I'm going. And that method is going to reinstall the apps and import each application, and at some point it imports our monsters models, and then it crashes. Now we can do the same thing with run server. It's a bit different. The stack trace is slightly shorter, and this time it's when run server hits a function called getAppErrors, which is related to model validation, that it raises the exception. And finally, if we do this with JUnit, the stack trace is significantly longer, but that's not the biggest difference. The biggest difference is that the exception happens when the first request hits the server. While with shell and run server, the exception happened as soon as I started the Django process, regardless of whether I was browsing the site or not. So here, the full story is that the auth middleware accesses a session, and Django attempted to use a database, and at that point, it calls appcache.get models, and then it crashes like before. Of course, all this is with Django 1.6, so this is fixed in 1.7. So, the lesson we can take from this is that we have an object called the app cache in Django.db.models.loading. There's a private function called _populate, which walks through installed apps and imports the models module of each application. And as a side effect of importing models, relationships between models are set, and specifically reverse relationship. So the reverse relationship is typically when monster has a foreign key to user, that's the monster set that allows you to traverse the foreign key backwards to look for the set of monsters that have been slain by a given user. And this needs to be done before using the ORM, because otherwise you could start an ORM query and it would fail with, say, an attribute error, simply because the reverse accessor wouldn't have been created yet. And so that's why, in all these stack trace, at some point Django starts importing all the models before you can touch the ORM. So during this process, there's another thing that happens, is that model classes register themselves with the app cache. So then the app cache has a complete list of applications, and you can ask it such questions as give me a list of all installed applications, give me a list of all models, give me a list of all models in this application, etc., etc. And you can see how this is useful, for instance, just to build the admin index page, which is a list of apps and models. Two last notes on this topic. First, you can see that there's an awful lot of global state. In Python, when you import things, you cannot unimport them. There's no support in the interpreter for doing that. And as soon as you import models, they get registered in the app cache. And so the app cache is very much tied to models you've imported. And that makes it almost impossible to test it, for instance, because you cannot reproduce a state of the app cache. It only depends on everything that has happened in the history of your application. Another thing is that I said that importing models sets up relation and reverse relation. That only works if all your models are defined or imported in the models.py module in one of your applications. Because if your model is somewhere else, Django will not find it until somehow your application imports it. And so you see that there you have room for a bug, where you could attempt to query a model before it's imported, and that would fail. Okay, so that must have been quite a lot. So we're going to make a short mid-keynote break and talk about some app cache facts. The first fact is that the app cache contains the hardest bug ever in Django. That bug had a 7 rounds against Malcolm, and it was related to the population of relationships for many-to-many fields. And I'm not even kidding, because I checked the git log, and you see that this is the number of change sets that reference a given ticket number. And all those that have more references are either refactorings or batches of commits or sequences of stuff, or well, they're all cheating. And so bug 1796 is really the hardest bust ever in Django. I would like to demonstrate the kind of interesting behaviors this bug introduced. We're going to define some models. Well, really, there's nothing magic in there. So we define an empty model that has just an identifier, and we set a class attribute equal equals true. And then, just because we can, we override it, and we decide that monsters are nice, and we set equal to false. and bad luck. So if you check demonstrable as all this, it is true, obviously. Try it, it works. The reason for this, well, I mean, if you keep a copy of the original class, in fact, monster after this is still the original class, which is fantastic. So that's why evolving is true. And so the reason for this is not even an accident. Somewhere in the meta class for model, so that is the class who defines how model classes are created, it used to just create a new model class and return it. And then this class would be bound to the monster name in my example. And it was changed in a bug that reference bug 1786, so the famous hardest bug, to return a get model that is to look up the model in the app cache. And so in my example, that line looks up the monster model in the app cache, finds the original model and returns it. And why does Django do something so stupid? That's because before Django 1.4, for those who have been in the community for a long time, Django encouraged a pattern where you had both a directory and its parent directory on Python paths, and you could actually import things through two different Python paths depending from which basis you started. And for models, that was a huge problem because if you had two copies of your model class, you wouldn't know whether relations pointed to one copy or the other, and it would just be a mess. And so this was introduced to ensure that there was only a single class for a given model, no matter how you imported it. So I will let you imagine how messy this can get when you start digging into Django's internals. A few more scary bedtime stories. So the first one is not actually scary, it's just that the app cache is a singleton based on the borg pattern, which is this pattern with the coolest name ever. Besides, it's pretty simple. You take a dictionary which you set as a class attribute of the class, and in init, you set the instance, double underscore dic, double underscore, to be this dictionary. So you can have several instances of the class, but they share the same state, and so they behave exactly the same. So it's almost a singleton, and it works as a singleton in practice. So for the record, this also went away in 1.7 because that was a big problem for Andrew's migrations project. It needed two app caches to handle state changes. A better one is that app.populate takes the Python interpreter import lock. That's not stuff you do in day-to-day programming. The reason for doing this is that since app.populate is going to import a bunch of modules based on installed apps, it could deadlock with the Python interpreter itself if two threads, say two threads of a Django application, hit different import sequences and deadlocked. That cannot happen in the interpreter because it takes this lock, but it could happen with Django. So that was fun. It became even more fun when in Django 3.4 they got rid of the import lock, and so we didn't know how to deal with that. So fortunately, it's gone. And there was a bunch of other things I'm going to skip because populate I saw had some fairly complex behavior, so that when if it accidentally created an import loop based on the sequence of applications that attempt importing, it would abort if it hit an import error and retry later, and I could never convince myself of whether this is just by accident or if it could prove that this actually allowed importing all possible Django applications. Okay, I hope by now all your brains are melted. That was the goal. And we'll get to more concrete stuff, and we'll talk about what's new in Django 1.7, and so what are the new fancy features you're going to be able to use. So when I started working on this in December, I started with a huge wall of text on the Django developers mailing list, because that's how you kickstart a project in Django. And I set a list of goals that I wanted to achieve. And in fact, I had only 3 goals in my list. because I wanted to fight the scope creeps that had pretty much killed the project until then. The first one was to allow apps without a models module or package. I think almost everyone here must have spent 15 minutes figuring why Django wouldn't load a given application, and that was simply because the application had no models and you had neglected to create an empty models.py. There's no reason to create an empty models.py. So I really wanted to fix that. It was a small thing, but it was annoying. The second one was to provide a purpose name for the admin. That was one of the original features requested in Ticket Search Environment 91. And since I'm not English, I always need to translate my purpose name, and that was also annoying. And the third one, as I explained, it was to be able to register signals reliably. So that there are various ways to look at this, but the general idea is I need a way to run code when Django starts before it does anything else. I'll get into some details for all the goals that I achieved just later in the presentation. So I also had a bunch of non-goals, which were things that had been considered in the history of uploading that I would try to do if they were possible and easy, and would just give up otherwise. The first one was allow changing app label. So that was the second part of the original feature request. It was a label app label on purpose name. So this works. The next one was to allow changing DB prefix. So that one I didn't fix. So the idea is when you have an application and models, table in the database are conventionally named app_model. And so the request was to allow changing the app part of this. So interestingly, this was a feature request made by Aaron Swartz, ticket number 1891. And so that's the sort of thing you discover in the history of Django. You get famous people. And so anyway, it was close one fix, because you can do this with a meta.db table. You can define a meta class in your model and just set the table on every model if you want to, and that's good enough. Next, I wanted to clarify the app cache population sequence, because like I said earlier, there was a bunch of very, very dubious code added to work around edge cases and all this stuff, taking the import log, backtracking on import errors, retrying, etc. It seemed very fragile. And then I also wanted to enforce consistency between installed apps and the app cache. What happens in Django 1.6 is that if you import a model from something that isn't an application in installed apps, Django sort of tolerates it to some extent, but not completely, and sometimes it fails, and it's very hard to diagnose. So I thought it would be a good idea to prevent you from using models that aren't in installed apps, and enforce that the app cache contains exactly installed apps. And finally, that's at the end of the list. Finally, there's some less likely goals and most of them didn't achieve. The first one were API for auto-discovery. For instance, Django auto-discovers template tags at a conventional location inside packages. It discovers admin.py. It also discovers templates, so these are Python modules, these are files. The reason why I didn't tackle this is that, in general, it's a bad idea to auto-discover things in Python. Because that means that you're going to arbitrarily import a bunch of modules, and importing a module in Python isn't neutral. This can just run code, this can do literally anything. So one should not import modules lightly, and it was more responsible not to provide an API for this. Then regarding file system, there's the API of app config classes is good enough for this, so there's nothing needed. App admin, it was a somewhat related ticket, but not that much related. The idea of app admin would be to provide a way to customize how applications appear in the admin. But at the moment, there's not much to customize besides the name of the application. So well, it's open if someone wants to do something interesting in this area. Another idea was app-specific settings. Many applications require you to add things in your settings, in your settings module. And some people feel like it would be better to namespaces per application. Django gives a lot of freedom as to how to organize your settings. Probably half of the people in this room have written a settings organization application at some point. So I think it's better to leave it up to each developer. Then there was the issue of order of installed apps. So it can happen in Django that you look up a resource like a template in applications, and there are two ways to do this. You go through installed apps, and either you take the first one or the last one. You can take a random one, but that wouldn't be very interesting. So the idea of this ticket was to make this consistent, to ensure there's a simple rule that you can memorize or at least look up its documentation. And finally, the last one was the most ambitious one, and that was where the PyCon 2008 sprints gave up. Well, the dream of uploading was to make it possible to deploy 2 copies of an application. Like I have Django.contrib comments. I want 2 sets of unrelated comments. But this raises some very complex issues. Like for instance, if comments as a foreign key to user, when you do user.comment set, to which set of comments do you refer? Because the expectation would be to have two database tables for each model, etc. So in terms of API, it's extremely messy, and many people have been discussing this as something that just needs developing, but I think there's some very structural problems with these ideas, and I don't expect this to be implemented in Django ever. I will now get a bit more into details for each of the goals that I achieved. So apps without models, there's not much to say. So get rid of your empty model.py files and enjoy clean applications. A verbose name. So this is an example of how you, let's say, a pluggable application can declare a verbose name for itself in the admin. That's something that's tied to the application, so you want to customize this inside the application and not at the project level. So the convention is to create a module called apps.py inside the application, and you define a class there that inherits app config, and you define a name, which is the name of the application this app config applies to. This is very important because when Django is going to load the app config class, it has no way to know which application it applies to if you don't tell it. So every app config class has a name, that's absolutely mandatory. And then you simply become a verbose name. So that's good, but if you have people upgrading from an older version, say, and they just have rock and roll, the name of your app in the settings, you don't want to have to tell them to change the settings because it's going to be complicated in the docs and they're going to get wrong and you're going to get tons of hate mail. So there's an escape hatch for this. It's a bit controversial, but by convention, if you define default app config in your application's root package in init.py, Django will use this class. So basically, what this does, if Django says rock and roll in app installed apps, it will use rockandroll.apps.rockandrollconfig instead. So that's the config class you just defined. So that's the model for third-party apps. And then it's magic. You get what you expect. Yeah, fantastic. lots of work for a few pixels. For the startup hook, so I say that I added a way to run code when Django starts. So you do this at the application level, since most of your code lives in an application anyway, and all you need to do is implement a ready method inside the app config class. And in Django 1.7, when Django starts, it's going to import all your applications, then all your models, and then it's going to run all the ready methods. So it's a very good place to register signals simply by importing the module where they're registered, for instance. And so typically if rock and roll had signals, you would do it that way and put your signals in signals.py, just next to apps.py. So now you remember that one of the original ideas was to change app label if there's a conflict. Until Django 1.6, to some extent, you can get away with applications that have the same label, that is the last part of the Python path to application. And David looks at me with pain because Oscar relies heavily on this. So in Django 1.7, that's one of the things that I say to forbid as part of the effort to remove all dubious edge cases, but I added the possibility to relabel an application, which means that it will be exactly as if your application had a different name, and to do this, you simply declare label equals something. And for example, the label for the first app will be core billing instead of billing, and the label for the second one will be web billing instead of billing. So that's interesting if you want, for example, to separate your applications between core stuff and UI stuff. As in this example. So this is typically something you would rather do at the project level rather than at the application level, because it's a problem when you integrate multiple apps together. And in this case, well, the convention is to put this in an apps.py file next to urls.py and wiki.py, etc. And settings.py, of course. Now, app registry population, I think I spoiled it a bit earlier. So when Django starts, it's going to call explicitly a function, Django.setup, to do all the uploading. So you can no longer have the various stack traces as I showed at the beginning, where Django would blow up at a non-deterministic point if there was a problem in your models. So this is also much better because it provides strong guarantees that if you have an error in your code, it will break as soon as you start the server, not when you get the first request, at least for your models. And also, since Django is always going to start by importing the models in the application and models in the order of installed apps, applications always get imported in the same order. In previous version of Django, you could have cases where, depending on the first request that hit your application, you would either successfully boot your Django process or crash with a circular import error, which was extremely tricky. So anyway, if you're running a Django server that's serving requests, get with the application, call Django.setup. If you're running a management command, execute from command line, which is the Tarpas function, also does this. And if you have written standalone script, that is, you have just created a plain Python file, you're setting Django settings module in the environment and you run it. In that case, you must add import Django.setup at the beginning of the file, otherwise you will hit an error. So that's a backwards incompatibility you must be aware of. Regarding app cache consistency, there are a few new constraints. First, apps must have unique labels. This is backwards incompatible. If you have two apps with the same label, you have to relabel one of them, like I just showed. Then, if you still have code that imports models through different paths, I don't think that's possible unless you've done some very weird stuff when you've upgraded from Django 1.4, when you must fix your imports and just use the same system where you import everything from the same point in Python paths. This is also backwards incompatible, but I think everyone has fixed this code already. Django previously had a lot of flexibility about where you could define models. Now it's going to insist on models being defined in an application that's in installed apps. Concrete models. This doesn't apply to abstract models that you can keep wherever you want. You can bypass this rule if you need it by providing explicitly an app label, that is, the application declares I'm belonging to this app. But I'm strongly encouraging everyone to just put models inside the PY because it's avoiding tons of problems that can still happen in some cases. Sorry, this is just a bit too complicated to be explained in 45 minutes. And finally, the last one is probably going to be the most annoying. The app cache is basically a two-level structure that has a list of apps, and in each app, which is, well, basically the app config class, it has a list of models. And, well, to populate this correctly, you need to have imported the app config class before you can start attaching models to it. So I've implemented deprecation paths because this is probably going to be a problem, especially if you have applications that import models in the root package. Because in that case, when you're importing the application, you're already importing the models, so you lose. It's generally a bad practice to import too much stuff in an application's root package, but Django, the contrib.admin, is absolutely the worst in this area, so I'm in a bad position to give lessons. Well, that's an error that can happen. All this is documented at next in the release notes, so don't worry if you haven't memorized it all. Finally, regarding the order of installed apps, almost all parts of Django 1.6 and earlier go through installed apps in its order and take the first resource, the first matching resource they find. So if you want to override something, your application needs to come in installed app before the thing you want to override. There was one exception, management comments, they work the other way around. And I think it's just an artifact of history because no one paid attention to this when implementing this stuff 10 years ago, 8 years ago. So I've brutally reversed the order for management comment in 1.7, so this is totally backwards incompatible. The biggest problem would have been for South, which overrides SyncDB, one of the most commonly used apps. Fortunately, since we also have migration in 1.7, well, it's going to be a different problem. So we're lucky. But if you have overridden management comments from other apps, you need to probably you may have to reverse the order from application for apps. I just said something stupid about SyncDB. In fact, this is not a problem for SyncDB because management command in applications always override core management command, and SyncDB is a core management command. Never mind. So before I reach the end of my talk, here is a very quick overview of the app config API. So we talked about appconfig.name, .label, .verbose name. I didn't talk about appconfig.path, but this is a file system path to the root of the application, and so you can look into subdirectories to find things in there if you want to. You have appconfig.module, which is the root package, and models module, which is well, just inside the model module. These are mostly used internally by Django. You shouldn't need them in general. And then there are three functions. Get models and get model, which simply do what they say, there's nothing fancy in there, and ready, which is the hook for startup code. And I said app cache during the entire presentation. This is a small simplification. The thing is now called the app registry. Since I basically threw it away and wrote it, it felt appropriate to change the name. So we will have to retrain to say app registry instead of app cache. And the way to use it is to import apps from Django.apps. And then you have a few methods with get app configs, get app config, get model. So as usual, the semantics are extremely simple. This is a public API. Previously, the API was a private API. So now you can feel free to use it. It's no longer a hack. Just one word about the last one. Apps.isInstalled is required. Well, it takes an app name that is a full Python path to the application. Because, for instance, if you want to check if the admin is installed because you're doing something that depends on the admin, you check if apps.isInstalled Django.contrib.admin, and that works even if for some reason the admin has been relabeled. So you can't look it up by label because it's possible to relabel. Now, a few upgrade tips. I expect the upgrade to be a slightly rough experience. You can show the slides if you need it. A common class of error is going to be runtime error. App registry isn't ready yet. Basically, this happens when you run code that depends on the app registry at import time. That is while the app registry is still in the process of updating itself. And so common causes are using you get text triggers the translation machinery that looks at translating application, so use a lazy version instead. Get to the model, pretty much same story, use a lazy reference with just the string reference to the model. You can also, instead of computing something, create a function that computes the thing and cache its results, for instance, with functools.lru cache. This is available in Django.utils. And finally, if you do stuff at import time, in fact, you should just move it to app configured ready and be done with it. And don't forget Django.setup in standard scripts. The other problem you may encounter is import errors. Most often, if you have an import error that goes through apps.populate, that's a circular import. So that will happen for all third-party apps that perform introspection by themselves, basically. So say Django debug toolbar, but that's fixed. Haystack, probably others. So check your dependencies and make sure you don't have circular dependencies between your applications. Try to have a tree of dependency. This is a good practice in general, trust me. And if you're doing dynamic models or weird stuff and you are using the Apache kernel, etc., basically you're screwed. But you're temporarily screwed. It's going to be better afterwards, so it's for your own good. So you should thank me. Okay, oh wait, one more thing, and then I shall have. In the 1.6 template, there's this nice URL, the py file, and I have a huge problem with this because there's something that is not an URL, and I'm OCD about these things. Unfortunately, in the Django 1.7 template, that thing is gone, and it's much more elegant. And why is it gone? Because it's done in admin config not ready, like it should. And the admin's default tab performs auto discovery of admin.ui modules, and so you can remove this from all your world accounts. Thank you very much.